Hello everyone, this is KP the Math G, and I am here tonight to discuss question number 6 from the 2017 free response questions. Now they had 3 parts to this, actually, well, four part question, but they had 3 things here. In other words, they had a table like this, and then they had a graph, and then they had an equation. But part D is only dealing with this part right here. Okay, you have x and you have g at x, you have g prime at x. So in other words, g is differentiable, which means, by the way, that g is continuous. Now that's important. Now, whether you're a student or a beginning teacher, this is your first year, just know that, and I can't help but believe that you teachers know this, but anyway, just as a refresher, if anything is differentiable, it is continuous. Okay, anyway, these are the values. Here's x, g at x, and then g prime at x. Okay, part D. I'm redoing part D because in my 140th video I had exactly 31 minutes, and I tell you what, I got maybe a little bit halfway through with part D, and I got cut off, and I apologize for that, so please forgive me for that, and I will try in the future not to do videos that long. And I started to cut it off after part C, and I thought I could squeeze D in, but evidently I could not. So we're going to do it this time, and it may be a blessing in disguise that we did not do this one or get this one in the last video, because it is talking about a different concept. It's not really having to do with the derivative, but it has to do with something else. I don't want to reveal that right now, but I will reveal it shortly. And it just has to do with a really good theorem that is used in calculus, and I'll get into that theorem in just a moment. The question asked, question D is there a number C in the closed interval -5, -3, such that g prime at C is equal to -4? When I see this, a number C in some closed interval, and I see these 3 parts here, a number C, and I'm looking at it in this closed interval such that g prime at C is equal to -4. For those of you who might know this, think about it. I wish you could tell me out loud what it is. Well, anyway, if you are thinking of something called MVT, you are exactly correct. This is the mean value theorem, and the mean value theorem has to do with, you have 2 lines. You have a tangent line to a curve, like so. I don't know. You have a tangent line to a curve, and then you have a secant line. Let's see here. Well, this is writing so, okay, now maybe, okay, right here. Ugh. Okay, right there. Ooh. I'm trying to make it tangent, and that is not even near what I want to do here. Okay, Let's see if I can do this. Okay, right there, maybe so. And so this is your secant line, and this is your tangent line. And is the secant line parallel to this tangent line? Is there a C such that in this closed interval, some closed interval, such that G prime at C, somewhere this line, this derivative, this slope is equal to -4? Well, first of all, it would have to be a lot steeper than that to be -4. But you have the idea. The lines must be parallel. The slopes must be the same. Is the slope of the secant line equal to the slope of the tangent line? Is there a C somewhere in there that would make that true? Okay. There may be more than one. Okay, but we are interested in just seeing if there's one at all. So what do we got to do? Well, we got to find, according to the definition, we're looking at, let's see, we're looking at G at -3 minus G at -5 over -3 minus -5. And we want to know, is this equal to -4? Is there a number, is there such a C such that this G prime is equal to, this slope is equal to -4? Well, this is the definition of slope here. Okay, let's see if it's so. G at -3, let's look at it, is 2. Alright, I'm going in the order. If you go -3, -5 here, you must go -3, -5 here. Minus sign in between. Alright, we should know that. This is slope. Okay, slope is going to have that minus sign. Keep that in mind. So what we have, 2, G at -3 is 2, G at -5 is 10, so 2 minus 10 over, now this is of course plus plus, we should know that, that's fundamental. -3 plus 5 is 2, and look at this, this is -8 over 2, which is -4. Now, yes, there is at least one. Now what we have to do is explain this. Alright, so let me see if we can come up with a good explanation. Now first of all we got to state that G is, and I've said it verbally, but we got to say G is differentiable. I'm just going to abbreviate that, which implies, what does that imply? That G is continuous. That's right. I'm just going to abbreviate that. And first of all, for this to work, you must have something that is differentiable, or at least continuous. Alright? And so, yes. Yes, by now the mean value theorem, you have to quote that. There is at least, there could be more, there is at least one C such that, that's a word, isn't it? That does mean such that G prime C is equal to -4. Now, you also need to state there is at least one C. Maybe let's just go ahead and say a little more than that in this interval, on the interval, not the closed interval, but according to the mean value theorem, we're talking about the open interval. I'm not including -3 and -5 on this open interval. All right, and we might say interval. Forgive me. Okay, now, so they'll know this is not a point, this is an interval. Okay, now such that G prime at C is equal to -4. Now, had we not gotten this, we cannot make that conclusion. The question is there a number C in this closed interval such that G prime at C is equal to -4? Okay. The slope of the tangent of the tangent line is equal to the slope of the secant line. Okay. There is one in between those two numbers. Okay, there's at least one. Okay, there could be more than that. All right, but anyway, that's what you have to put down. Make sure that you talk about this one. That's number one, and then get your interval. Get that here, at least one. Get that, and then now such that. And of course, we did get this over here. Now that's, boy, I wanted to. I wish I could do something else, but that's pretty much what I have in mind here. And once again, I do apologize for going too long on the last video. I was still hoping, if I probably had about another 30 seconds, I probably could have gotten all of this in, and we wouldn't be doing this in like, what, 5 to 10 minutes. So anyway, well, be that as it may, I'm just happy to be able to do this. I'm going to do a few more videos. I'm looking at some. Well, I'll be looking for some here pretty soon. Of course, here recently, my wife and I, we travel a lot to see family, and actually we hadn't long celebrated our anniversary, so we enjoyed all of that. And I don't want to get into any detail about talking about the anniversary, but we had a really good time together. And of course, we got home and we had work to do. We got a couple of gardens to look at, small gardens, but still gardens nonetheless. Got a few things to, a few fruit and vegetables to harvest and all that. So we do that, and of course take care of this yard too. Pretty nice sized yard here that we got to take care of. So anyway, so much to do. And I do help out with clothes and dishes. Not the dishes so much, but anyway. But anyway, KP the Math G. I appreciate everyone. If you would, if you'd like to hit that subscribe button. I've got a few subscribers, quite a few. Would like to have more, but then again, if I don't get more, that's quite all right. It's all about you understanding this. You know, I always like a like button too. That strike that little like that. Let me know. I mean, be genuine. If you really like it, yeah, hit the like button. If you'd like to make a comment, please do so. Please do so. I appreciate any comment that you would have to make. Anything I could do better or something like that, then I would be open to that. But anyway, I appreciate all of you. I appreciate anyone who is listening to this and watching this. It means a lot to me. And it means a lot to me that you understand this. This is not always an easy concept to discuss, but it is a major theorem. Rolle's theorem is probably a portion of this MVT. They kind of feed off of each other, if you will. And you have others that we look at it as well. The intermediate, I want to say IVT. EVT, I want to say the extreme value theorem. That's very important, and that gets shown quite a bit when we talk about absolute maxes and absolute minimums. Yeah, some people call them global maximums and minimums. So, yeah, we get into that discussion too. So anyway, all right. Anyway, KP the Math G signing off at this time. Ladies and gentlemen, I appreciate every one of you, and all of you have a great, great day.